So now we'll talk about segment addition, which is a more specific name for what I was talking about earlier, and that's that the whole thing is just always equal to the sum of its parts. And that has to be all of its parts, of course. So what would that mean here? Well, that means that if I take the segment AB and the segment BC, if I take those two things and I add them together, they total up to the same thing as AC. And hopefully you can see that here. If I take both these pieces here and just stack them together, well, I can see clearly that they form the same thing. There's a couple things I'll point out. One of the reasons we know that for certain is, based off the drawing here, A, B, and C are all collinear. And so that means that, for example, if I had something like this, A, B, and then C, like so, well, then obviously I can't, and it's a little harder for me to articulate, but here, clearly, AB plus BC is not equal to this, because these two segments don't directly combine to create AC. So hopefully you can kind of see the difference there. And again, this is something where practice eventually hopefully makes it a little easier. I'll also point out that the notation that I'm using here is not necessarily correct, because you usually add together lengths. You don't add together segments themselves, but I think it illustrates things a lot easier to kind of use that familiar addition notation. So I'll add in here that obviously if we take the lengths of these things and combine them together, the two pieces will equal the whole. And so from there, let's again look at this in the context of some algebra, or let's even just start with a really simple example. If I knew that this piece here was 3 and that this piece here was 5, I would of course know that this piece here had to be 3 plus 5, which is of course 8. So looking at a simple example here, that makes perfect sense. So what if we didn't know one of those values? For example, we didn't know that this was 5. Well, we could go ahead and use a little bit of algebra, and we could find that missing value. What would the length of BC have to be if we wanted this particular figure to be real and exist? And in this case, you probably don't even need to use much algebra. We already saw that that value is just 5. 3 plus 5 equals 8. And we can put it in our drawing, which I always recommend doing because it'll help us to kind of look at it in context and make sure it actually makes sense. And there you have it. There's a simple example and explanation on the segment addition postulate. In the next video, we'll go ahead and take a look at a more complicated algebraic example of this.